Today we're going to be talking about CDMI and how it can help enable deployment management of web applications. Today we're going to start by giving a quick refresher of what is CDMI, the Cloud Data Management Interface. We're going to talk about CDMI as a superset representation of various data formats, and we're going to talk about CDMI enabling web applications. So, quick refresher. So, the Cloud Data Management Interface is intended to help clients manage data that's stored in clouds. CDMI is intended to solve three problems. It's intended to solve the question of how do we enable rapid innovation in the cloud while still having the benefits of a standard? How do we generalize the management of data that's in the cloud? And how do we provide a standard management interface for clients? So we'll have our cloud, we'll have all these different types of data stored in the cloud. We may have container-based typical file systems, hierarchies, directories, and files. We have object stores, key value stores. We may have structured data, streams, queues, tables, and we may have graph representations. So these are all typically different types of data stored in the cloud, and these have different interfaces and different management mechanisms, and for clients that want to do consistent management, both across data types and across clouds and across on-prem systems, this is complicated because you have to write to all these different interfaces, which are often slightly different, and that's very expensive. So we want to have a standard way to do this. So one of the things that CDMI provides is a mechanism by which clients can request clouds to provide value-added functionality. So, for example, a cloud may provide data protection services. And each cloud is going to have its own different interfaces for managing this data protection services. But as a client, I may want to say, I want this data protection for this data. And as the data moves around between cloud to cloud or cloud to on-prem, I want that property, that declarative request for that capability to be sticky with that data. So in order to do that, we need two different things. First of all, we need a standard way that a client can state what it wants to have happen with the data. The second part is we need a way for an implementation that's providing storage services to recognize that that specific behavior is being requested and map it to the internal functionality of the cloud implementation. So we have built upon the SNIA Storage Industry Reference Design Model, that's the SIRDM, and organize this functionality into three groups. There's what we call storage services. This is very basic. You retain the data, you provide access control on the data, you provide basic metadata like how big is a piece of data, etc. Then there's your data services. These are the next level on top. Things like data protection, integrity verification, versioning, retention, etc. This is specific to storage. Then there's the next level on top of that, which we call information services. This is more specific to the contents, the semantic format, processing of the data itself. Things like data format transformation, feature extraction, tag extraction, triggers, functions as a service, all these sorts of additional value add on top of the underlying storage that has to now be aware of the content and the format, etc. You may have a service where you want thumbnails automatically to be generated, as an example. So some of these are standardized. We all have retention pretty well figured out. Some of these are application specific, some of these are vendor specific, and some of these are very experimentational. So we wanted a standardized mechanism to allow, as these move from experiment, vendor specific, through to standardized, that you can define metadata that then allows this communication between the application and the storage system in a standardized way. So that's the second piece. CDMI leaves the internal data representation and the internal implementation and the internal data management up to the cloud. So this way we're not trying to dictate how the cloud is implemented and how the cloud operates, but rather providing that kind of connector metadata between what the client says and what the cloud consumes. So this helps solve problem number one. We're not going and defining any internals inside the cloud. But in order to have interoperability, we have to have some mechanism to connect this together, and that's this declarative metadata. So corresponding to each of the three, the storage system functionality has storage system metadata defined. The data system metadata defines the data services, and information system metadata defines what you want from that next level on top. This generalizes the approach for managing, connecting the client's intent to the storage being able to service and provide that. And this is how we're trying to solve problem number 2, which is providing that interoperability. When a vendor implements functionality and has a CDMI interface to exchange this metadata, there's a set of standardized metadata that's already defined, and vendors can add their vendor-specific metadata for functionality specific to their cloud that isn't standardized yet. And as additional vendors support similar functionality, they can get together and add that standardization. Okay, so these metadata, there isn't a standardized mechanism for across all these different formats to get metadata for objects in the cloud. So what we've done is we have gone and we have defined a protocol called CDMI, which says, I have this cloud accessible resource, a URI. Well, how do I manage properties of this? What we did is we said, CDMI says you can take any URI and you can do a standard REST operation against it and say, give me the CDMI representation of this URI. Doesn't matter what it is. It can be a file, it can be a folder, it can be a LUN, it can be a table, a graph node, etc. As long as you have a URI, you do a get on that URI, say accept CDMI object, and you'll get back a JSON document that says, here's the metadata for this object in the cloud. We don't care how it's stored internally. This is client-facing, so we wanted to use the exact same semantic, the exact same access mechanism that a client would use to access that data. So, this makes it really easy to add, because if you can go and do a get, an HTTP get to a URI, you can now implement CDMI. And if you want to set the metadata, let's say you want to specify a retention for some data, etc., you just go and you do a put to that URI with the content type CDMI object and specify that metadata, and now that's a standardized request to the storage system saying, hey, I want to attach this additional metadata to that object. And this also provides your discovery, so you can go and see what's already there and what's available. Okay, so now we've got this mechanism. We got a protocol saying I can go and look at this, and we can now look at which exports and how this data is made available to clients. So because this is a bootstrapping operation, I can't go and I can't talk to a storage system until I have configured it so clients can access it. CDMI also provides a solution to the problem of how do I configure how I want my data to be exported. And this is important because data may be exported in multiple different formats using multiple different protocols. The simple example is I may have a file system exported via NFS, via CIFS. I may also be providing it as an S3 bucket. CDMI provides a standard mechanism to say, I want this resource to be exported via this protocol and this configuration in a multi-vendor standardized way. Okay, I'm going to go really quick because I am running short on time. So I'm going to give a quick demonstration of what this looks like. So live demo, hopefully this all works because I was getting some errors. So I have a listing, Apache listing style. This is just using a CDMI operation to discover what namespaces are available. So if I go and select a namespace and I look at the CDMI representation, what this is doing is just an HTTP GET saying, I want to see the CDMI representation of this data. And it's saying, okay, the object name lib64 is imported from this location. It could be exported to another location, NFS, CIFS, etc. It has some basic metadata, creation time, etc. It has some children. There we are. So that's a basic CDMI operation. And you can see some of the metadata there associated with it. If that object was under retention, you'd see some retention metadata. And if you wanted to put that object under retention, you'd add some retention metadata. And I should note, CDMI is an ISO standard. We're at version 2.0. We're currently working to bring this to 3.0. And this is done in the Cloud Storage Technical Working Group of SNIA. So if anyone's interested in this, there's a public spec available. You can just look at the PDF online, and we welcome people to come and get involved as well. So another thing CDMI supports is a superset representation. When we look at all these different types of data, they have different characteristics. They're organized differently. Some are linear arrays of bytes, some are collections of resources, some are collections of rows or structured tables, etc. They have different identifiers, primary identifiers. Some are hierarchical, some are not. Some are accessed by different mechanisms. Some have different types of metadata and expressiveness of metadata. CDMI is also there to help provide a representation for data mobility. So the CDMI representation, you can go and you can say, hey, this data, I want it packaged up into a serialized format for moving from one system to another. And it will go and it will take the data, whether it's files or whether it's LUNs or whether it's objects, etc., extract all of the data that it can get and send it in a serialized JSON format, which you can then use to reconstitute that data in another system. So that's another capability of CDMI. And what this means is that often you have different types of ways data can be expressed. So for example, if you look at S3, S3 is often used to represent a file system. But S3 is actually a key value store. So this leads to interesting things where you can have a S3 object named /files, etc. And this means that S3 can represent data that isn't expressible in a standard file system. So CDMI has to be able to capture this information, otherwise you're going to have data loss at the input stage. When you have data movement, you don't want data loss at the input stage. It sometimes is acceptable to have data loss at the output stage if that's what you want. But the ultimate transfer format has to support this. So we have been working through, in CDMI, the ability to have objects that have children and files and directories that have values. And this is something we need to support these kind of full set of data that we're seeing out there in systems today. So one of the things, this is something we're working on right now in standardization around S3 exports for CDMI. And this allows a CDMI data object to have a container representation and a CDMI container object to have data representation. And I will give a very quick demo to show how this works. Okay, so I have a running system here and I have some curl scripts. So I'm going to get a file as an object, right? Pretty normal. I go and I see I have a value. It says hello world, right? That's what you expect for a file. Let's go and look what it looks like to get that file as a container. So now we see, okay, it has no children. In some cases, it may have children, but the point is we're now looking at it as if it was a directory. So you have that duality. If you say, I want to look at this piece of data as if it's a file, you get one representation. If you want to look at it as if it's a container containing children, you get another representation. Same object, two views, one superset of data. Likewise, if you get a directory as a container, you see here I've got some contents, there's some children in here. But if I do a get that directory as an object, I now have a value. In this case, there's nothing in that because it's a standard directory. But the point being is that you can see those two different representations. Okay, so how does this relate to web applications? Well, a web application is often a collection of files on a file system that are exported via HTTP. So one of the things that CDMI lets you do is export via various protocols. Well, HTTP is a protocol. We're going to be able, you can use CDMI to specify that. So when we do this, now you can just drop a bunch of files onto a file system, and using CDMI, you can say, I want this to be exported via HTTP, and because web applications typically just end in slash, we can use the file object duality to say that a directory has contents that starts your application. So let's go look at what this looks like. Okay, so I have a directory here inside test, and I have a test file, and I have my application. I just dragged this in via the file system. And inside the application, there's a bunch of resources. There's JavaScript, there's CSS, there's other assets. So if I go back and I look at this, I see that it's exported via HTTP. And now I have an HTTP URL that I can use to access this data. So if I go into here and I look at my application, I can take the URI for that application here, and I can open up a browser window, and I can say, go to this URL. This is the URL to the application that I exported via HTTP. And notice that it's not going to index.html, etc. This is the URL to the equivalent of a directory. And when I access it, it's loaded up a JavaScript application, so showing a intrepid engineer walking through the tunnels at CERN. And this was just as easy as dragging a file in, exporting it via HTTP, and then going and accessing the data. So that is my third demonstration. The goal of this, why is this of value? Well, we've demonstrated how CDMI provides a standardized protocol for exporting and controlling access to cloud resident data. We've demonstrated how CDMI facilitates multi-protocol access. And we've demonstrated how CDMI exports allow you to, for example, take a packaged web application and easily publish it for access. And these are all significant challenges and areas where CDMI can help in a standardized way. So, are there any questions before I close my presentation? Okay, thank you very much. I appreciate you coming, and if you would like to ask me anything afterwards, I will be here for a few minutes and we can have a discussion.